All right, well, let's give a big warm round of applause then to Daniel Constantin Mierla and take it away.
Thanks, Travis. Thanks, everyone, for coming here for the presentation. Glad to be back. I missed a couple of editions of ClueCon in the recent years, but yeah, it's good to catch up with everyone. I actually made a presentation in two parts. As I said, I'm trying to catch up with you on what we have been done lately. So that will be the first part, what's new with Kamailio, and the second part, it's the tools about elasticity and scalability. My job is a bit easier, at least with some of the components, because Simon approached the one with, dispatcher, dynamic updating the destination list and so on. I still have it. And then don't miss the presentation from Fred on Thursday, because also Proxy, it's one of the nodes that really matters in terms of scalability. As I got the introduction, the project has quite a long history, couple of changes in the name, but anyhow, practically we have a continuous development since 2001. And it started at the research institute, the Fraunhofer Focus Institute in Berlin, Germany. I was working there as a researcher. It got to the market being quickly rather popular in terms of, voice over IP services, and in terms of scalability, being a signaling only SIP server with a proxy architecture behind. And yeah, it started as a SIP Express router. We evolved it in OpenACR and later Kamailio, which is the current project. So now back to the recent years. So the past 2 years, just to have an idea, I'm not going to go to all of this. I'm trying to focus more on what we did on the configuration file and some flexibility. But I just listed in case you see something interesting, you can approach me during the breaks, and I can give you more details about all this new development. Worth to mention that since Fraunhofer Focus somehow got out of the management and being the main developer of the project now it's community oriented. There are many companies contributing in different directions, from IMS to WebRTC to the classic voice over IP services, of course, integration with NoSQL and plugging in technologies like JSON, making easier to operate between nodes is something that we work quite a lot. And then our scripting language, I know many faces here, but also there are many new people, as I could see. And if you are not familiar with Kamailio, practically our configuration file, it's a scripting language. And you would see in the last years we did some great work there to make it easier for you. So practically now you could write the routing logic, how we call our dynamic part of the configuration file, in different scripting languages. So we still have the native one, but then we added support for other popular scripting languages like Lua, Python, JavaScript, lately Ruby, and some maybe not so popular like SQL scripting language. In terms of more details about all these new features, you have the links down there, so you can follow up after. However, I'm now going into this discussion about the scripting languages in Kamailio. Always, because somehow SIP ended up to be the next generation protocol for telephony. One of our main drawbacks when we got the old telephony guys coming into the space of IP was the configuration file, because they are used to this prefix-based routing, number-based routing, no concept of logic. You'd have like prefix 49 routed to Germany, right, or prefix 33 or whatever country, and so on. And the other bit kind of pressure from the configuration file point of view was, you do some changes there and you had to restart Kamailio. That's not a big issue overall because Kamailio is a proxy, it's not a telephony engine. Practically think about it as a SIP message router. So we get packets, SIP packets, and we route them left and right. We can modify, add headers, all this kind of operation to the small extent of each piece in those SIP request responses. But then some people got, the feeling that, okay, I need to do a small change. Should I restart it now or wait, or what happens? So practically restarting Kamailio during a call, there is no interference with the active calls. And usually we don't actually track active calls unless you load some modules. So in terms of performances, when someone asks, okay, what's the maximum capacity for Kamailio in terms of active calls, is like unlimited. We count the performances in terms of how many new calls per second we can route. Anyhow, this is another discussion. I did a presentation in the past at ClueCon many times about these aspects and the architecture of Kamailio. So please approach if you need more details if you are new in the space. Why we needed this and how we design it, practically the new way of executing the routing logic, we ended up of using this Kemi framework, so Kamailio embedded interpreter interface. To understand it better, practically Kamailio config file, you could think of it as two main parts. One would be the passive one, which is used only at startup, listening socket, how many processes to create, the decision you do before starting Kamailio and before receiving any SIP packet. And then is the runtime, the active part that it's used during Kamailio execution. It's the routing blocks, where you get, okay, I got an invite, it's from Daniel, it goes to 49, so I have to do a list code routing on this number and sending out. Those are the routing blocks, and practically it's what we give you now as an option to use either Lua, Python, or something else instead of our native scripting language. The scripting language is still there, but what we did is like unifying when you write a new C function that you want to export to the configuration file, so it's practically available in all these scripting languages at once. We had these scripting interpreters for quite a long time, not all of them. Some of them were added lately, but like Lua, it's one of the oldest since 2010 or so. But they were more for inline execution. So you had to use the native scripting language where you use like Lua exec, and you gave some function in a Lua script to be executed with the parameters. So again, for the new people here, I put on the right down corner how it looks like a route block inside the Kamailio config file. You have some condition there, like if, some action, appending header, and sending out. In terms of just as a summary to end up this part, practically now the scripting engine allows you to use Lua, JavaScript, Python, and Python 3. There are two modules because of the difference in the APIs in this scripting language engine. Squirrel, a small scripting language, not that popular, but could be sometimes useful for embedded devices. And the last one was added is Ruby, which I added a few weeks ago. There are some older interpreters like Perl and .NET and some Java one that actually I haven't worked with most of them, and they were not upgraded to implement this Kemi interface. So practically we have them still available, but only for inline execution. Now again, picture that route block SIP out, because now you could see the difference between what's this native scripting language and how it looks like in Lua. So practically, we don't have the route as a keyword anymore because we don't define the scripting language. You have to choose your function name, and then what to export there, it's an object, KSR, standing for Kamailio SIP routing, and all these functions. So you could spot the KSR, HDR, append header field. So practically, it's a submodule for working with headers, and we append a header. Again, practically, if I'm going back, this is the native one where we have just append header field, and then we have the Lua one. And the same is with the Python, just, it's a different scripting language, different way of defining a function and blocks and if conditions, but you could spot that they are more or less quite similar. So transition from one to another, it's rather simple. There are some documentation. We're a bit behind on full documentation, but should be like one-to-one relation between the function in these scripting languages and the function in our configuration file, native scripting language, which is all documentation. So it's more like a reference what we do here in this development tutorial for Kamailio Chemi framework, and then there is a link for example, so you can have like a starting point if you want to use Lua, Python, and so on. So this is the rather big change that we had in the past few years, like enhancement. So now you can choose your language as your preference, but also you can do reloading. Native is still not reloading because we do a lot of optimization at runtime, but with the Python, Lua, and the other, you can do reloading at any time. Another work was a bit more in like non-SIP processing handling, because there are different needs, like doing more encryption rather than plain text, or dealing with other protocols, not UDP, TCP, plain text. You can have all kind of what we call event routes. So here is just an example. I don't want to explain it of how to use Perl for compressing or decompressing large SIP messages that you pass between the instances. Also like Homer, SIP capture, and so on, acting as a proxy. Few more examples. So NoSQL, of course, different engines, support for them. RTP engine became like mainstream in our project, being developed by Kamailio developers. So lately they added the transcoding capability, but in terms of scalability, it's better than the old RTP proxy. Stronger authentication, topology hiding and topology stripping. A lot of work on IMS voice over LTE extension, not much involved in that myself, but you could see it from the commits and so on. I'm ending this part by providing you the links where you could read more about this feature, and let's move on, not to be too late for the launch. So again, please approach if you want to discuss about the new feature in Kamailio in the past 1, 2, 3 years. I'm available during all these days at ClickOn. So first, with scalability and elasticity in the era of cloud, we start from the edge node, and again will be Fred going deeper into this use case of Kamailio. But always I try to highlight the dispatcher module. Okay, I'm the initial and the main author of the module. Still a lot of contribution out there. Also, Julian here has a presentation, but he's has done a lot of nice feature lately, like congestion control, routing-based capability for dispatcher. So it's still quite dynamic in terms of new features. However, it's your first stop if you need to scale from the edge to a list of media servers, transcoding, and so on. It's a rather simple use. I typically try to put some example here. Is more or less like the route blocks you have to add to the default configuration file, because there you have authentication, authorization. I didn't try to put all these extra layers in the config file, just focusing on the topic I want. So dispatcher, it's an old one. It's available out there for a long time. The README of the module, the documentation for the module, has a more complete configuration if you want to start with it. And the second one that was somehow tuned a bit more lately, it's also to be used at the edge of your platform, would be this capability of transparent proxy or Anycast. So as I mentioned before, we try to stay out of tracking calls. We could do it with dialog, but typically in some nodes you want to be more or less as stateless as possible. For rerouting purposes, you have to be transaction stateful. So if you send to one node which is down, you would like to reroute to another one. So this is the typical use case for Kamailio. However, when you do the Anycast, you can send the request on this node going to the client whatsoever, but the reply could come on another node. So practically with some small adjustments to what we had for a very long time, like from the beginning, it was this send function, which is more like mirroring the traffic. But we needed to add a bit more flexibility here. So if you work with many network interfaces, you could now like receive a message and on this network interface, but you say, okay, I want to consider it was received on another one. So practically you have like 20 cast nodes. Even if you receive it on a private link, you can put it in the config file execution as has been received on the public, the one that interfaces with the client. So again, it's not really big changes to make it develop, like big development in to make the Anycast a bit more flexible in the configuration file. You have the examples there, so practically you have to mark the request with the server ID, and then when you get the reply based on that, you can pass it transparently. When I mean transparently, if you are familiar with SIP, you know that proxy needs to add or remove some headers. Transparent proxy is like, I just send it out without really consuming via header or without consuming or adding record route or route headers. And then you can add your own headers if you want, because you control the behavior of Kamailio, and we want to have a full control as admin of your SIP platform. In terms of the socket control, there are two functions. Practically is like, I want to set the source IP and port and protocol, so you can overwrite the one you actually received on, because if you have Anycast, you somehow communicate on a private network and you see the source IP, it's the other peer of my Anycast. Now you can, on the first node, you receive it, you get the source IP of the device, and then you put it as a header, you pass it to the other node, and the other node will just set that as being the source IP of the SIP message. And you can then go with the normal SIP processing, like doing NAT traversal, checking headers with source IP and port and things like that. And then it's about the local socket, because if you transmit on a private network, then for real communication with the device, you have to switch on the socket that connects to the public internet or whatever kind of network you connect to the client's VPN or so. So this is the transparent proxy Anycast. There is a complete config file, more like minimal, but at least with two nodes, and how you have all this logic along with authentication and things like that in our repository I added a few days ago. Next that I want to approach in terms of elasticity, it's trust between the nodes, because when you have cloud deployment, it's like, okay, you can rely on permission module, which allows you to trust some IP addresses, but it's not really that elastic as we expect. Of course, you can update the database, issue, reload, but sometimes it's hard to know the IP address of a node if you use like Amazon in China now, because there is an attack there and you want to collect some traffic on that one. It would be hard to propagate the IP address of a new instance that easily. So again, it's still usable with permission, but a few years ago I added a new module that tries to rely on signing packages. It's this authx keys module. So practically it's working on a shared secret between your nodes. And then when you receive a packet, before sending out, it's your choice. So we don't enforce it from the C code. So it's not like, okay, it's open source, someone reads the C code and now can guess what you add there. It's up to you to choose what headers you sign, how you name your new header that it's propagating the signature, and so you receive it on a node, you sign it with your secret key and pass it to the next node, like you have the edge node. Now, as I said, launched it on Amazon Cloud right now. It's receiving traffic, it's passing to the registrar. Now the registrar is looking for the same header, and based on the same share secret and the expression that it should have been signed, like here we sign on source IP of like the server IP address, the from URI, request URI, and the CSEC, and the other node will check it if it's matching. And then practically you don't really need to pass all these or propagate IP addresses via database and so on. It's practically on spot. I have a new node, it's adding this header with this expression of building it, and all the other nodes should be able to authenticate because it's gonna match. Of course, sometimes it's also about the client side in terms of elasticity, but also in terms of more security. We focused a bit on having it stronger. You would have to build it or use your own clients because the old SIP phones are still using MD5, but as we saw in the previous presentation, people are starting building more and more their own apps for that, so you can make it stronger. And then don't forget that TLS, this one helps also a lot with scalability. You can use self or sign certificate by yourself. You are certificate authority if you want, and based on that you can trust new nodes in the cloud and so on. And then there are a couple of optimization that you could do also for mobile networks, especially like if you have a trusted connection, even if it's with username and password, so the client doesn't have a certificate itself, it's only the server. Practically you can trust and avoid this round trip with challenge 401, 407 for authentication. So this is something that you could keep in mind to have a more scalable platform. The next topic, so it was authentication and security, would be, propagation of the state's replication. And there are a couple of options. The first one that we had there was TM with T-replicate, but was more like manual configuration file on each node. Then some or this Anycast and so on, it's in Corex with send, and not so new, it's the DMQ module, distributed message queue. So this is having capability of auto discovery of the nodes when it's up, when it's down, and practically you just, when you start a node, you have to inform what would be first peer to contact with, and then that peer is pushing back information about all the other nodes it knows about. So yeah, DMQ, if I'm not wrong, starting like 2010, 11, and it slowly evolved in being used by many other modules like user location, presence, dialog. So it's now the foundation for distributing states between Kamailio nodes and the auto discovery of the services. The decision was to be done by using SIP packets, because Kamailio is a SIP router. If we are not able to route a lot of SIP packets, then we are doing something wrong. So we were not looking at reusing other protocols or inventing our own binary replication or text replication, because again, they are there, but we thought if we do it on SIP, we have full control. And now practically you get the packet in your config file, and it's up to you to reroute it or up to you to handle in the way you want. So you have the full flexibility as for any other SIP traffic. We use our own method. It's KDMQ here. It's an example of propagating location record. So a new registration is then broadcasted to all the nodes in the platform. I'll have a bit more example of scripting. This is the SIP message. As you could see, it's plain SIP, and it's easier also to troubleshoot. People are familiar with the tools. They see, oh, it's a loop, I don't reply, or maybe I don't update the request URI, or I don't put the right one when it comes to my configuration file. Smart routing would be what Simon somehow approached before in the talk. earlier today, relying a lot on the dispatcher module. This module has a lot of flexibility in terms of routing algorithms and so on. It's up to you how you discover new services and you build a new destination set and issue a reload to Kamailio. And then when it's using other services, you could rely on RTJSON, which defines a JSON document for routing logic. So it tells back to Kamailio what to set in the request URI, outbound proxy URI, path headers, what socket to be used for sending out, managing some headers in terms of updating the caller ID, callee ID, and so on. Practically, you can build your Node.js or whatever application for deciding what to route out, and you just need to push back. Kamailio can just say, okay, I have a call from Daniel to James, and you push back a JSON, and Kamailio does the routing with retrying, serial parallel forking, and things like that. Now, a bit more technical in terms of propagating this routing information, because again, you want to be dynamic, you want to be elastic, you don't really want to start writing in text files by yourself. The first option would be this hierarchical routing propagation, which is more the concept Skype used or defined some time ago, these super nodes. So practically, you don't really want to have the information in all nodes, because then you have maybe elasticity, but you don't have scalability. Once one node is full, all the platform is cap it up, because you cannot push new registration, the node cannot take it. So the idea is to partition. You have these nodes keeping a lot of information about devices, like, you know, in a location table, we have call ID, we have source IP, we have the contact address, we have path. If you replicate everything for everyone, then practically you don't really scale that much. What you can do actually is to inform the supernode, okay, Daniel, register now to the Kamailio server in Chicago. If you in Berlin, someone is calling Daniel, ask me if you don't find it locally, and I will forward it to Chicago, because I know. So practically what we propagate here is when someone registers, we inform the supernode, hey, Daniel is with me. So it's Daniel at kamailio.org and the ID of Chicago, or the IP of the Chicago server. I'm not going to explain it. I just want to highlight here. So the code is working, but I'm not going line by line. What you see in the red is the addition to the default config file. And there is no new module that you have to load. Everything is public there. It's UAC module that when we get the register, informs the supernode about, let's say, the home server of that registering user. So again, the red lines are the addition to the default config file. Otherwise, what you see in blue or comments are part of our Kamailio configuration file. The second approach would be more like horizontal routing, when you don't really want to have this hierarchy. Everyone knows everyone, but now we don't really replicate everything. Like I said, we just inform again, I am the home server for that user, but everyone has it. So instead of having like 20 attributes for each registration, I have 20 attributes for the user that registered to me, and then only one attribute for the other users that are online, respectively the ID of the node or the IP address of the node, which is the home server for that. For this, you can use DMQ, which I already presented. So practically, again, the red lines here are the addition you have to put in the default Kamailio config file. We handle in the request route the KDMQ message. So this is the request sent by DMQ module. If it's for store, we expect there to have user ID, like user at domain in the body. And what we do, it's actually saving the source IP and port, which is the home server that sends us the message on the message queue. And then for the registrar, we do the usual save location. And then if it's not a registration, so it's a registration, we do a broadcast, DMQ bcast message. The first would be like the channel store, and the second it's what we want to store as a key. It's from username at from domain, and this would be put in the body and the content type for that body. On the right side there, we have route location. It's in the default config file. Practically, if lookup location fails, so doesn't find the user online, we call this subroute to home server, which practically we look in the hash table if we have a relation between the user ID and the node address. And if yes, we set outbound proxy address to that home server of that user and we send out. So again, this is classic open source Kamailio, and the addition you have to do are rather minimal. People expect to be something complex, but really they don't are that much. And I'm ending now with just some notes about elasticity on the vertical scaling, so more processing on the same instance. Just to remember, I had a presentation about asynchronous processing with Kamailio. So it's something that you should have in mind, especially if you deal with database when you are in cloud, and the database is also in cloud, could be quite a delay or long time execution of the queries. You can go with asynchronous processing on this kind of operations. And ending up with highlighting on this, topology hiding, topology stripping. With cloud, you can have many nodes, and maybe you want to hide it from the devices or the people you interconnect with. We have two modules. One is like scalable or elastic by itself, by design. Topo module, because it's relying on this shared secret between nodes, so every node can route as long as they have the same secret. And topology stripping, Topos module, it's relying on Redis for distributing information. This is more towards like back-to-back user agents. So instead of hiding IP addresses of the nodes, it's stripping them and push them to this queue or Redis channel for propagation to other nodes. So if this node goes down, the other node can route the request within the dialog without any issue.
Hey, Daniel. Perfect. Beautiful.
I'm done with this one. Hopefully not too much into the lunchtime. Maybe one question or so if you have. Otherwise, I'm around again.
You can catch Daniel at lunch. That'll be perfect. He'll be around all week. Let's give a big round of applause for Daniel. That was wonderful.
Thank you.